For the first time ever, we are going on a mission to a star. NASA's Parker Solar Probe sets out to travel closer to the sun than any spacecraft before Saturday. And if all goes well, it just might change the way we look at our solar system. The Parker Solar Probe is slated to launch August 11th on board a Delta IV Heavy with upper stage rocket, lifting off from NASA's Kennedy Space Center in Florida. Joining us to discuss, Betsy Congdon, lead engineer on the heat shield for NASA's Parker Solar Probe. So Betsy, explain to us why this is so groundbreaking and what you're actually hoping to learn from this mission.
This is such a groundbreaking mission because we've never been this close. To kind of put it in perspective, if the Earth and the sun were on a football field, we're getting within the 5-yard line close to the sun. So we're getting really close. And there's a lot about the sun that we don't understand, even though it's such an important part of our solar system and it's our star. It sounds a little technical, but we don't understand how the solar wind is accelerated, which is a really important feature of the sun and affects our life here on Earth. We also don't understand why the corona is hotter than the surface of the sun. The corona is that hazy region that we all saw when we looked up at the eclipse last year, and it's hotter than the surface of the sun, which doesn't make a lot of sense. So we're actually going to go into that region and study the waves and the particles and the fields to understand what's going on at the sun.
Now, you were instrumental in developing the heat shield that will actually make this all possible. Talk to us about the technology that you've been working on for, as I understand it, 9 years to make this happen.
Yeah, I have been working with a team of people for the last 10 years working on developing the heat shield. The heat shield itself is about 4.5 inches thick and about 8 feet in diameter, but it only weighs about 160 pounds. So we like to call it our 8-foot frisbee. It's a really low, lightweight composite form of carbon-carbon and carbon foam. The front side, when we get close to the sun, will actually be at 2,500 degrees Fahrenheit. But the spacecraft during that time will only be at 85 degrees Fahrenheit. So we're keeping everything cool behind our shadow.
So talk to us about the timeline here. When do you arrive? When do you return?
So the spacecraft will be launching tomorrow, and then we will go through our first pass of the sun, actually in November. We go through 24 passes in the next 7 years and get closer and closer to the sun using Venus to actually, as a gravity assist, to get closer and closer to the sun. So it's a 7-year mission. And as we get closer and closer, we're going to learn more and more. But that first pass that's happening in November, we actually expect to get data back shortly thereafter, and we'll start learning new things about the sun right away.
So, I'm curious, once we get this information, how will that change our lives? How does this information arm us with potential new possibilities?
So space weather is a really important phenomenon, and how it actually can affect our satellites that are going around the Earth itself. It affects their operation occasionally, and so understanding why solar storms happen and what happens is actually really important to our life here on Earth. Additionally, as we start exploring other regions and sending astronauts out farther and farther, they can be affected by these storms. And so understanding why they happen and what happens and how the sun actually is interacting with us is actually vital to us understanding how to actually interact with our star. And we hope to also understand more about other stars by exploring our own.
I got to ask you, space has become such a controversial new frontier. You've got the Trump administration now proposing a space force. Is that something that you given all of your work in space, think is necessary to invest in?
I don't have anything to say about that.
Well, what are you most excited to learn then on this particular mission? When you get that data back, what are you going to be pouring through for that first piece of new information?
So there have been hundreds of thousands of people who have made this mission possible, and just being part of that team has been so special. And I'm really looking forward to I know that we will be rewriting the textbooks about the sun, and we'll be learning completely new things that nobody could have ever imagined. And to be a small part of that is just so amazing.